recording. Okay, welcome back to the Thursdays with Me program. It is June 30th. We're going to do some miscellaneous problems in coordinate geometry. And this is actually I think the last one of these programs before the next one's not until July 28th, I want to say. Don't absolutely take my word for that, but I think that's the right date of the next program because there's some kind of unpredictability in my schedule until then. So that's why we've had these last couple of these back to back. But there you go. Okay, we're going to do some miscellaneous problems in coordinate geometry. We just went over the rules, and here again is the copyright notice. These problems are all from the free software of GMAT Prep, which is from GMAC. Notice again, when you submit GMAT Prep problems, they can't be from the paid version of the software. They have to be from the free software. But, all right, unless otherwise notified. So let's do one. How about this one right here? Okay, and remember this is a data sufficiency problem. We do expect that if you are attending this workshop, we do expect that you have a base level of familiarity with how data sufficiency works and what the answer choices mean. But here is where you find the multiple choice options. Again, underneath your name, you'll find A, B, C, D, E options. Please use those. Please do not answer in the chat box. Okay. Give you a little bit of time for that. Okay, we're going to take a little bit more time if you need it, but shouldn't take you too much longer. Remember how this exam works too, right? This is a test where you can't not pick an answer on this exam. So in other words, there's no such thing as leaving a question blank, and there's no such thing as moving on and coming back to it later. There's no such thing as any of those. So you gotta pick something. So, and also don't forget overall what time management means on an exam like this one. Like on this test, basically time management just means if you are stuck, then you stop doing what you're doing and you just either quit and guess or you try another strategy if you can think of one. That's it. But basically that's all that time management is. I mean, a lot of people are under this weird impression that that time management has to do with minutes and seconds or something like that, which time management has nothing to do with that at all. It's really just, am I making progress with this problem or am I not? And if you're not, you just quit. People are asking the chat box if it stopped. It didn't stop, guys. I mean, people are still working on the problem. So, yeah, okay. Anyways, what I find weirder is that both of the people in the chat box who are asking whether it stopped have not even answered the question yet. I mean, you gotta pick a multiple choice, guys. Right there where it says pick a multiple choice. Didn't pick one yet. Neither of you guys. Okay. So let's pick something. Okay, so let's discuss. First of all, I mean, again, in these Thursday workshop things, we do expect that you are familiar with the basics of data sufficiency. But if you picked A, B, or D on this problem, if you don't really know what's going on with data sufficiency, then that's fine. But otherwise, that is a really, really big issue. Like, in other words, it should be really very immediately clear to you that these statements are individually not sufficient. Like, that should be, not even exaggerating here, that should be clear within probably 2 seconds or so. So, and if it's not, then that's an issue, guys. So, for the individual statements, I'm talking about statement 1 individually and statement 2 individually. It should be clear, like literally within like 2 seconds, that the individual statements are not sufficient. Why? Why is that? Because it asks for the midpoint of CD, and if you just have one or the other of those individual statements, then, yeah, I mean, you at least have to have some piece of information that pertains to both points. I mean, if you only have something about C and not D, and you only have something about D but not C, then you, like, because the other point can be anywhere at all. Like in statement 1, D could be literally anything. I mean, also, there's the other problem that these are variables. So this could be anywhere too. So, I mean, there's like double problems of freedom here. You know, like if you have this statement alone, I mean, first of all, A and B are unknowns, so this point could be anywhere. Also, D could be anywhere too. So that's like literally these 2 points could be actually any 2 points in the entire plane, as long as A and B are positive. So, yep, that's not going to be sufficient. So A and B and D are out. So we just need to combine the statements. So in terms of procedural efficiency here, like if you had not combined the 2 statements by the time you were something like 15 seconds into this problem, then you got to work on efficiency, guys. Thing. So, okay, 2 statements combined. Let's combine the 2 statements. Let's do that. There's basically 2 ways we can do this. The same 2 ways we can approach every data sufficiency situation, really, which are, you can either use an algebraic approach or you can test cases. So let's just look at both of those. I mean, so, okay, Gabriella says let's test cases. So let's try testing cases first. Let's try that. So we know that C is the point A, comma, 1 minus B. And we know that D is the point 1 minus A, comma, B. Okay. So what are we going to pick? Like when we test cases, how do we start that? Like what's the most efficient way to begin testing a case here? Yeah, you give values to A and B, because then once you have A and B, it's going to generate the points C and D. And then you're going to find the midpoint of those. So yeah, pick A, pick B, and then point C. So first you find A. C is A, 1 minus B. Then D is 1 minus A, B. And then what's the midpoint? Yeah, so it's, I mean, okay, someone's saying smart numbers in the box. I mean, you should really have different names for 3 different procedures, which are back-solving smart numbers and this testing cases procedure. Like smart numbers is a thing that you do for multiple choice problems. And in that procedure, that's like picking 1 number for each quantity. And then normally, unless you have coincidental answer choices, you're done. So it's different. Like here, you have to pick multiple values, and the goal is totally different. So Neo's talking about algebra. We're going to do algebra later. So again, right now we're talking about testing cases. So you can do either of these approaches. They're both legitimate approaches. Neither one is better than the other. So but we're going to do that in a sec. So okay, but we can just pick. We do have to pick positive values for A and B. So let's do that. Positive values for A and B. Okay. So let's just start by picking random A's and B's. So if we had, sure, 2 and 5, okay. Then A, comma 1 minus B is 2 minus 4. And 1 minus A, comma B is negative 1, 5. And then the midpoint of those is the average of 2 and negative 1 is 1/2. And the average of negative 4 and 5 is also 1/2. Okay. Now again, remember the point, when you test cases in Datasufficiency, the deal is if you end up with more than one outcome, then that's not sufficient. So now that's basically what the point is. Like now we're trying to see if we can end up with anything other than this. If we get anything other than this, that's not sufficient. If we just keep getting the same thing over and over again, then that's sufficient. Okay, I mean, we can try fractions. Mahima says let's throw some fractions in there. Okay, let's try some fractions. So if A is like 1/3 and B is 1/4, then A is 1/3 and 1 minus B is 3/4. And 1 minus A is 2/3. Okay, halfway between 1/3 and 2/3 is 1/2. And halfway between 3/4 and 1/4 is also 1/2, so same point. if you are really stubborn, you can keep trying, but you'll discover soon enough that the same thing will keep happening. I mean, you just keep testing cases, then you'll just keep ending up with the same thing. Keep trying, you'll keep getting the same point. And again, I mean, really, you shouldn't keep trying that much. Like, one thing about this test that is super consistent is that you don't really get fake patterns, and you don't really get fake persistence of results that are not actually persistent results. So if you get the same thing more than like 2 or 3 times, you should just be like, I bet this is a permanent result. And sure enough, it is. Yeah, totally. So this is sufficient, and this is C like cat. So any questions about testing cases here? Smiley face, this makes sense. Okay. I mean, you can also do this algebraically. Sure you can, right? So let's do that. This is the same problem. Let's see. If you're going to combine these things algebraically. Let's say you want to take an algebraic approach. So you have the coordinates of C, which are A, comma 1 minus B, and D is 1 minus A, comma B. The midpoint, to find the midpoint, just take the average of the x coordinates and the average of the y coordinates. So the average of the x coordinates is, you just add those up and you divide by 2. So add A plus 1 minus A and divide by 2. So that gives you 1/2, because the A's just cancel. And then the average of the y coordinates is going to be very similar, right? It's going to be 1 minus b, and then you add back b. That's going to cancel as well. So that's going to give you 1/2. So look at that. The midpoint is 1/2, 1/2. So that's sufficient. So you've got an algebraic approach. You've also got testing cases approach. These are both absolutely legitimate approaches, and they both work. So again, remember, when you review these problems, the point is just to find as many ways as you can of solving them. I mean, the point is not to try to figure out what is, quote, the best way, unquote. The point is not to try to make a hierarchy of anything. The point is to just diversify your approaches as much as possible. Right? Like, literally, the more ways you have of doing these things, the better. That's the only goal here that we have, is to just have more and more and more ways of being able to solve these things. So, and I mean, also, as far as your personal strengths and weaknesses, remember that you should always emphasize things that are currently your weaknesses when you review and study. So if you tend to do things algebraically all the time, then when you review, you should study mostly things like this, testing cases and stuff. And if you tend to do things like this more often, then when you go back and review and study, you should emphasize things like algebra more. It's just like anything else, right? It's like if you were an athlete who was really strong but not fast, then you would train speed more than strength, and vice versa. So, okay, any questions about this? Go ahead and chat them. Otherwise, we will try another problem. Let's try. Toby is typing questions, so wait just a second for Toby to type a question. if it didn't give you this restriction, I mean, what's interesting about this problem is that this problem would actually work out the same way regardless. The only thing they're doing by making those numbers positive, the question is if, well, let me just, in case anybody's going to watch this later on video, let me put the question on the screen. Okay, the question is this. Okay, what's interesting about this is that for the most part, the positive number restriction is not super relevant here. But let me just tell you what they're doing with that. What they're doing there is they're just trying to make sure that C and D don't end up being the same point. So, because if actually no, because if A and B are both 1/2, then they are the same point. If A is a half. Actually, yeah, that restriction does nothing at all, now that I think about it. If you remove that restriction completely, then the problem still works the same way, which is unusual. Normally when there are restrictions like this, the restriction accomplishes at least something. Even if it's trivial, like sometimes the restriction just makes sure that you're not dividing by 0 or something like that. But you are right when you say this, yeah. I mean, if you were not told, if you're not given a restriction, then you have to make sure that you don't accidentally impose a restriction yourself. Yes. But what's interesting in this problem is that it actually doesn't even make any difference. So, strange. Okay, let's do another problem. Try this one. What is the x-intercept of the non-horizontal line L in the xy plane? That technically that should have been that line that should have been there at the beginning. So I'll put it there now. Okay. Go for it. Okay. If you don't have an answer, you should probably pick one pretty soon. Does anybody know what the answer, like, there's an answer to this problem that you're going to break my heart if you pick. Does anybody know what answer that is? -40. It's a Datasufficiency problem, though. I mean, there's an answer A, B, C, D, or E here that if you pick it, if you pick this, there's a certain answer here that if you pick it, it means you kind of just don't really understand the whole point of data sufficiency in general. Which answer is that? It's different from, what I'm not saying is that it's obviously wrong, because there are two answers that are obviously wrong, and those are B and D. And nobody picked those, so that's good. Because like this statement is clearly not sufficient, right? But okay. Here. If you picked this choice right here, if you're in this group, that pick this answer, if you pick C, if you pick this, then you still don't really understand the main point of data sufficiency. Let's talk about that. So, I mean, but first, let's get rid of this problem for a second. Let's talk about a much simpler problem here. So here is a very simple data sufficiency problem. If I said this, I was like, okay, what is 2x plus 2y? And statement 1 is this. And statement 2 is this. Okay. So you guys know what the answer to that problem is, right? Like, just tell me in the chat box what's the answer to that. Okay, that's A, right? So now there are two ways in which people could theoretically approach this. Okay, the right way to approach this is I don't care about X or Y because they are not the goal of the problem. I care about the goal of the problem, which is 2x plus 2y. That. When people who have that approach, people who are thinking, I need to find this, they're going to pick A. I think it's the problem right. The wrong way to approach this would be I need to find everything in the problem, including like X and Y. If someone thinks they need to find X and Y in this problem, then they're going to pick C, and they're going to get the problem wrong. And notice when this person, if you come into this thinking that you need to find X and Y, notice when you get it wrong. Like you actually get it wrong before you even start it. Like if you see this and you think I need to find the values of X and Y, then you have actually gotten this wrong before you even begin doing it. Yeah. So, and I mean, this is why they actually invented a separate problem type called data sufficiency. Because with a regular multiple choice problem, this is not a thing. Like if I gave you this much information in a multiple choice problem, you could just find X and Y if you wanted to. But data sufficiency has this unique format where you might use both of these statements, but you might not. And no one really knows until they do work. So that's the whole point. So smiley face if this makes sense. Like the point is you have to know exactly what the goal of the problem is. So the goal of this problem is to find the x-intercept of the line. So like as soon as you have a decent amount of experience with data sufficiency, like the instant that you see this, you should think, I need to find the x-intercept, and I am almost certainly not going to find the line. Like, if you think I need to find the equation of the line, you're screwed. Like, as soon as you have that thought, you have already gotten the problem wrong before you even start doing the work, guys. So, when you see this, That's what you should anticipate. Like literally as soon as you see this, think, I need to find the intercept. I need to find the x-intercept of the y. I'm not going to find the equation of the line. I mean, this is the single most important thing about data sufficiency, is that you are pretty much not going to find stuff other than your goal. I mean, same sort of thing in general. I mean, when you see data sufficiency problems, you should just think this. Like if you see what is the 10th digit of the number n, okay, you should think, I'm going to find that digit, and I'm definitely not going to find n. Definitely, definitely, definitely. If you see something like, is the area of this triangle greater than 20? You should think that you're going to find whether the area is greater than 20. But you should also think that you are definitely not going to find the area itself, etc. Because, I mean, again, you should just think about this from the point of view of the people writing the questions. Like, if I wrote a problem where you actually found the equation mx plus b or whatever, I would never think to ask you what the x-intercept is. Like, this question would never cross my mind. Because I would just be like, dude, what's the equation of the line? So just think about it, right? Like if the question writer even thought of asking you this in the first place, this is clearly the reason why. Because this is like some special piece of information that you find. So, okay. Any questions about this? Because again, this whole thing with specific goals, this is kind of why they invented this entire problem type in the first place. So make sure you don't underestimate the importance of this. Okay, also statement 2 is pretty clearly not sufficient because the y-intercept, it doesn't tell you where the x-intercept is. I mean, this means that it hits the y-axis at 0, -3. But that's nice, but that doesn't tell you where it's going to hit the x-axis. Yeah. Where the line hits the x-axis. So this is not sufficient. So if you had like 10 seconds to guess, you would actually be able to guess the answer to this problem already. You could already guess that this is A. Because again, if you know how data sufficiency works, then you know the answer is not going to be C. Because C would just be, oh, well, I guess the y-intercept is -3, and then m is 4 times -3 is -12, so the equation is -12x -3. But that's not how data sufficiency works. In any case, remember there are 2 ways to do data sufficiency. Let's look at both of them. Let's do testing cases for statement 1. How do you do that? Like what does a case look like for statement 1? Like what are you actually picking? okay, you can pick a slope, and then that'll give you the y-intercept, which is just 4 times that. And then that'll give you a line, right? So let's do that. So pick the slope of L. And then the y-intercept is going to be 4 times the slope. And then once you have that, so remember in our equation y equals mx plus b or whatever, the slope is the m value. And the y-intercept is the b value. So then this is the equation. Y equals mx plus b. And then we need to find the x-intercept. So to find the x-intercept, that means x-intercept is the point where y is 0. So remember, x-intercept means that you are on the x-intercept is where you hit the x-axis. And wherever you are on the x-axis, that means that the y-coordinate is 0. So, okay, let's try that. So, if the slope is 2, then the y-intercept is 8. So then that's y equals 2x plus 8. And again, to find the x-intercept, what you have to do is set the y-coordinate equal to 0. So you can just plug 0 into that equation for y, and then solve. So 0, and then that means that x would be -4. So the y-intercept is -4. Okay, just try with a couple more. I mean, now here's the deal, right? Not sufficient means you get 2 different x-intercepts. Sufficient means you're stuck with the same x-intercept every time. The way to make this efficient here is if you plug in like a really ugly value and get the same answer that we already got, you can just be done. You can trust that the answer will be the same every time. Because that would just be beyond all possible coincidence, right? So like, let's say the slope is something like -1,000. Sure, why not? Okay, let's do that. So in that case, the y-intercept is -4,000. So y equals mx plus b, -1,000x minus 4,000, and then set that to 0. If you solve that, sure enough, you're going to get -4 again. And I mean, if you are just so incredibly stubborn, you can try one more plug-in and stuff, but it's going to be -4 every time. And sure enough, that's going to be sufficient. So this is A, alligator. You can do that. And I mean, notice you don't find the y-intercept or the slope or any other point on the line at all. I mean, like this line could still have any slope and it could still have any y-intercept. But that doesn't matter, because that's the thing about data sufficiency, is that it it's very goal-oriented. Like in this problem, we find the thing we want to find, even though we find basically nothing else at all. So, smiley face if this makes sense. And we can also take an algebraic approach to it. Let's try that. So here is the problem, and let's try taking an algebraic approach to it. Let's just see, right? So to statement 1. So algebraic approach to statement 1. So the y-intercept is that's the b in mx plus b. And the slope is the m in the same equation. So that just tells you that b is for m. So how do you use things like this algebraically? Like in general, if you have an algebraic statement that some variable is 4 times some other variable, how are you going to use that? Does anybody have any automatic ideas as to how that can be used? You can just, what do you do with this? Yeah, just use this as a substitution, sure, right? So, I mean, use this, just plug it in for b. So you can plug this in to b in the typical linear equation right there. So that means the equation is now y equals mx plus 4m. But then remember, we want to find the x-intercept of that. So that means we want to find the point. So we want the x-intercept of that. So that's the value of x in that equation when y is 0. So if we plug in 0 for that, then if we get a number for x, that would mean sufficient, right? So if we plug in 0, then we can factor out m, and that gives us x plus 4. So now theoretically, this would mean one of two things. Like in theory, this would mean either m is 0 or x equals -4. But these are not both viable cases. Because we are told, like, why do we know that we don't have to worry about m equals 0? Like, why do we know it's not a thing? Yeah, we know that the line is non-horizontal. So m is 0 means you have a flat line with horizontal slope. So this rules out this. And so that means the only case that is left is this. So the x-intercept has to be -4, 0. And so that's sufficient. And again, if you were stuck at any point during this process, it's no big deal because you can just drop this process and you can start testing cases. You know, like the point is that whatever you're doing, you should not feel committed to whatever process you're doing. Like if you are doing algebra and you get stuck doing algebra, then stop doing algebra and just start testing cases. Same thing with this. So, any questions about any of this? Well, so I mean, the 0 case is ruled out, so that is irrelevant. I mean, 4 times 0 is 0, but that's ruled out because the line is not horizontal, so that case doesn't have to be considered here. But, I mean, yeah, I mean, of course, 4 times 0 is 0. Sure. So, okay. Let's do another one. How about this one? Okay, there are not very many people with answers yet, surprisingly. You should definitely pick something. So, in the next like 30 seconds or so. Okay, let's discuss. Let's talk about this. People's answers are like all over the place with this problem. There's actually almost equal numbers of people picking everything except for D. So, which is good because the answer is not D. But let's talk about it. So, I mean, this one's kind of mixed up a little bit with number properties. I mean, this one you're definitely going to want to draw a picture of. A couple of pictures, in fact. Like, I mean, if you try to approach this problem by thinking about equations of lines, you are very quickly going to find that this one goes nowhere fast. So, but is the product of their slopes negative? So also, remember what the goal is in the first place. This is a yes-no question. So we have talked about yes-no questions in a couple of these study hall things before, but I mean, you can actually search the archive for those previous sessions, so I can refer you to that. But remember, one of the main points of this is organizing the goals in the first place. So remember, the situation with a yes-no question is that if you can get the answer to be either yes, or you can get the answer to be both yes and no for a given statement, then that's not sufficient. So the yes situation here is the yes means that you can make the product of the slopes negative. When does that happen? When do you have a negative product? Negative product is one positive slope and one negative slope. So that's what you should write, right? This is one goal, right? So one positive slope, one negative slope. That's the yes case. What does a no mean? A no would mean that you have a product of 0 or positive. So be careful thinking it has to be positive. But so in other words, that could be basically any other situation at all. I mean, it could be one of them is a horizontal line, or you have 2 positive slopes or 2 negatives. So you can just capture that by saying basically any other situation. Those are the 2 goals. Okay. So then we want to see if that can happen for statement 1, statement 2, or possibly both. And so there's our organization, right? And we've talked about this in previous sessions. If you haven't seen those sessions, then a very brief example of a very brief explanation, rather, of what I'm doing here is because like the biggest problem people have with yes/no data sufficiencies is they don't even know what the goal is in the first place. The goal is basically if you can make the yes situation and the no situation both happen, then that's not sufficient. And so that's what you're trying to do. And so it helps to translate these specifically. So remember what this means. Like if you can make both of these happen, then that's not sufficient. And the point of this organizational device is for each of the statements, we just put a check mark in these boxes when we make stuff happen. So check mark for whatever we actually get to happen. And so then in a particular column, if you check off both of the boxes, then if you get 2 check marks in a column, then that's not sufficient in some particular column. So again, if you watch the other study hall recordings on yes/no data sufficiency problems in particular, then this will all make more sense. But smiley face if this makes some basic sense to you what we're trying to do here. Just to set up the basic goals of the problem. Because again, honestly, when the question is yes/no like this is at least 80% of the challenge, is that people do not even know what they're trying to do in the first place. And they don't even understand what the point of the problem is. And this is the point of the problem. So that's what a yes means. It means that you can get one to slope up and the other to slope down. And a no situation is literally anything else at all. Okay. So for statement 1, we know that we have the point 4, 3. So let's just put that point on there. The product of the x-intercepts is positive. So tell me, what does that mean? It means that, yeah, you have two x-intercepts that have the same sign. So this means you have to draw a picture so that both lines, either both lines hit the x-axis in the positive area, like on the right, or on the left. So both lines hit the right part of the x-axis, or both lines hit the left part of the x-axis. I mean, this is the condition that you have to obey. So in other words, you have to have both lines do this. So in other words, we can draw both lines hitting this part of the axis if we want to. So let's say that this, we can have this line and this line. So that is one positive slope and one negative slope. So that's going to check off the top box. And again, see, this is the point of organizing your goals like this, because now that we've written this, we know exactly what it is that we're trying to do, which is we need to still do this, but now we have to make a situation that is not one positive slope and one negative slope. So, okay. So there's the same situation. We can still have two positive x-intercepts. We can just draw two lines like this. There you go. So now these lines have two negative slopes. So this is not one positive, one negative anymore. So this just checks off the bottom box. So this is not sufficient for statement 1. Smiley face, if that makes sense. And again, if you don't have this sort of organizational device, this is incredibly hard. I mean, I know that I personally would be totally incapable of tracking that in my head. And even if you had a better memory than me and you somehow could track that in your head, it would still be much harder and much slower than it had to be. Like it definitely makes it much faster to take like 10 seconds of your life and make this device. It really does. Okay, statement 2. Same sort of thing, but now the product of the y-intercept is negative. So we have to have one x-intercept, one y-intercept that's positive and one y-intercept that's negative, according to the statement. So one line has to hit the top half of the y-axis, and the other line has to hit the bottom half of the y-axis, because that's what the statement says. So we can definitely get this to be one positive slope and one negative slope. There we go. And again, here is our here's our hitting the bottom of the y-axis, and here's our hitting the top of the y-axis. So that checks off the top box. Now the goal is we have to try to not do that, but we can do that easily enough, right? So we can still keep that bottom line. So that hits the bottom of the y-axis. Now we need to hit the top of the y-axis, but not have a negative slope. So we can do that as well, sure. Just do it like that. So that works there. So that checks the bottom box, and that's not sufficient. So now we got to combine the two statements. Any questions so far? Okay, so now what you've got, I mean, we have to combine the two statements. So let's think about how this has to work. So to combine the two statements, remember that you have to have one line with positive y-intercept, one line with negative y-intercept, and then both of them have to hit the same side of the x-axis. And also, they both have to go through 4, 3. So that's the other thing, right? Because, I mean, statement 1 by itself is pretty abstract because it could allow for the x-intercepts to be 2 positives or 2 negatives. But remember, you have to have one line. According to statement 2, you absolutely have to, no matter what. You have to have a line that has a negative y-intercept that goes through 4, 3. Like if you think about drawing that, no matter what, that line is definitely going to have a positive x-intercept because it's going to have to look like this. So, and once you have statement 1, that ties you to having 2 positive x-intercepts. Like because this line must have a positive x-intercept. That's the only way that you can get to the point 4, 3 from the negative y-axis. Smiley face if that makes sense. Just look at the drawing, right? You have to get from down here to up there. So then when you combine that with statement 1, that means that both of the x-intercepts are positive. I'm sure that does. Well, what do we know about the other line then? So we got this line here. The other line, the line we haven't drawn yet, has a positive x-intercept because it has to. And then it has a positive y-intercept because statement 2 says so. What does that mean? Like, what do we know about a line with a positive x-intercept and a positive y-intercept? Yeah, it's going to have a negative slope, right? The only way to get from the positive y-axis to the positive x-axis is to slope down. So I mean, you can draw it if you have to draw it, but if both of these things are true, then that means you have a line with a negative slope. And so that means no matter what, you have one line with a positive slope and one line with a negative slope. So that's going to have to be the first box. The second box is going to be impossible to achieve. So this is sufficient. And this is C like cat. And there you go. And again, if you drew pictures of it, you would soon enough realize that all of your pictures would be one upward sloping line and one downward sloping line. But the biggest challenge of this problem for most people is not anything to do with geometry or anything like that. It's really just organization and keeping track of what the heck your goals are, because it is, for most people, I mean, honestly, for most people, these yes-no questions in general, that's the biggest issue, is that no clue what the goals are. It's people just get lost, basically, and lose track of what they're trying to do in the first place. So make sure that doesn't happen. I don't see any reasonable way that this could be done algebraically. Which, again, is kind of the point of this exam. I mean, the whole reason why the GMAT exists is specifically to give you problems that not all of them can be done in the same way all the time. That's actually the point. So this is a problem that is pretty much not algebraic, and that's kind of why they give it to you. Okay, that is it. That is time. We gotta run. All right. I mean, you guys are welcome to experiment with it. See what you can do with it. I mean, I don't see any way to do that reasonably with a reasonable amount of work. But if you, especially trying to incorporate this in there, I'm not really seeing how that is doable. But again, that's the point of review, is to mess around with stuff and see if you can get it to work. So you are certainly more than welcome to try. Okay. Let's kill it. Long and difficult are absolutely not even sort of the same. In fact, in Datasufficiency, the hardest problems tend to be a little bit shorter. So, all right, the next session is July 28th, I do believe. So anyway, keep your eyes peeled on the web for any sort of scheduling changes and stuff. And I got a dash here, but thank you guys. It's been fun, and have a great next couple of weeks. All right.